Good morning, children. So we have started chapter 16. In the previous video, I had given you few notes on it. Okay. And today we'll do the exercise 16A. And before we go to the questions, let us try to recapitulate what we had done in the previous video. So in the previous video, I had explained that if you have a right angle triangle, let's say ABC, as you can see on the screen, where at B you have 90 degree and you have considered theta to be at A, then your perpendicular and hypotenuse, your perpendicular and base depends on the angle theta that you are considering, and like your perpendicular will be opposite to the angle theta and your base will be adjacent to that. Okay. And trigonometrical ratios, sine theta, cos theta, tan theta, and their reciprocals are given over here. Okay, so you should remember that if you're talking about sine theta, that means you're talking about ratio of perpendicular to hypotenuse. Okay, so sine theta is given by perpendicular by hypotenuse. So here theta was taken at A, so in that case perpendicular will be BC, okay, and hypotenuse will be AC. You should always remember that in a right angle triangle your hypotenuse remains fixed, but the perpendicular and base changes according to the angle that we are discussing. Okay, here we are discussing theta, that's why perpendicular is just opposite to that. That means BC is perpendicular and base is AB. Had I made angle beta over here, then with respect to beta, perpendicular will be AB, okay, and base will be BC. So this perpendicular and base completely depends on the angle which you are discussing about. And these trigonometrical ratios, you should remember that if you are talking about sine theta, that means you are talking about reciprocal of ratio of perpendicular to the hypotenuse. Okay, so and cosec is reciprocal of sine, so cosec theta will be hypotenuse by perpendicular, and when you take product of sine theta and cosec theta, you will always get 1. Okay, so when you're taking product of a trigonometrical ratio with its reciprocal, then you will get 1. Okay, so here cos theta is based by hypotenuse, sec theta is reciprocal of cos, which is hypotenuse by base. Okay, so when I say cosec is reciprocal of sine, that means I'm trying to say that cosec theta is 1 by sine theta. Okay, so if you have cosec theta written somewhere, then you can write 1 by sine theta also, no problem. Okay, sec theta is equal to 1 by cos theta. Okay, since sec is reciprocal of cos, and cot theta is 1 by tan theta. Clear? And here we had discussed about the relation between sine, cos, and tan. So tan theta is given as sine theta upon cos theta. Okay, and cot theta is given by cos theta upon sine theta. And next, I had talked about the identities. Okay, so first one is sine square theta plus cos square theta is equal to 1. So these three identities are very important whenever we are doing a problem related to trigonometry where we need to prove LHS is equal to RHS. So in those questions, these three play very important role. Okay, so here if you see, first one is sine square theta plus cos square theta equal to 1. So 1 is this, and from here, okay, you can write 2 more. Okay, so you can derive, like if you want to write sine square theta, then you can write 1 minus cos square theta. So sometimes you'll see that you have got 1 minus cos square theta. So straight you can write that is equal to sine square theta. Yes or no? Same way, from the same identity you can write that cos square theta will be 1 minus sine square theta. Okay, so along with this, these two are also important. Okay, but once you remember the first one, these two will come automatically. Okay, because these two have been written from here only. Now from this, if you want to write, then you can write sec square theta minus tan square theta equal to 1. Okay, and from here you can write cosec square theta minus cot square theta equal to 1. So once you remember these three, okay, if you once you remember these three, then this can be obtained from them. Okay, so this was simply recapitulation. Now I'm going to see exercise 16a. So here you see the first question is prove that number 1 minus cos square theta upon sin square theta is equal to 1. So here we will take the left hand side, okay, and using those identities what we have discussed right now, we'll try to show that LHS is equal to RHS. Okay, so LHS is equal to 1 minus cos square theta upon sin square theta. Now just now I showed you that 1 minus cos square theta, okay, is nothing but sin square theta. From the first identity, okay, this was our first identity. So from here, sin square theta is 1 minus cos square theta. So what we can do, in place of this 1 minus cos square theta, I can simply write sin square theta, and down already we have sin square theta. Yes, and you should mention reason over here, since sin square theta is equal to 1 minus cos square theta. So in that way, our numerator 1 minus cos square theta, it got simplified to sin square theta. Now numerator also sin square theta, denominator also sin square theta. These two will cancel and you are left with 1. Okay, which is your RHS proved. Yes. Question 2 is your homework. Okay, you need to do same as question number 1. Okay, now let us see next question. So next one is this: sin A into cot A is equal to cos A. Okay, so we will start with our left hand side and we copy it. So sin A into cot A. Now you know relation between cot theta, sin theta and cos theta. Cot theta is given by cos theta by sin theta. Since here we have cot A, then we'll get cot A is equal to cos A upon sin A. Sorry, sin A. Okay. See, if I'm writing theta over here, then these two will be also theta. Okay, whenever we are talking about relation between cot, cos and sin. So since here we have cot A, so we can write cot A is equal to cos A upon sin A. Yes, so from that we can write sin A, and in place of cot A I can write cos A upon sin A. Yes, and here I can give the reason. So cot A is equal to cos A upon sin A. Clear? Now once we have written this, you'll observe that sin A and sin A will get cancelled. Okay, and you're left with cos A, which is your right hand side, so it is proved. Okay, now let us see next question. So next is question number 4. Here we have 1 upon cos square theta minus tan square theta is equal to 1. And you should always remember that in order to solve this type of question, there is no such hard and fast rule that you have to do it in this manner only. Okay, it completely depends on you how you're going to make use of uh, those identities to simplify your question and prove it as per the requirement. So it's not necessary that the way I'm doing it, that is the only way of doing it. You may do it in other way also, but at the end you should be able to show whatever is required, and you should be able to make proper use of the identity. Okay, so don't think that there is only one way of doing it. Now see this one, left hand side done. We have to show this whole thing is equal to 1. Here you can see 1 upon cos square theta minus tan square theta. If you try to recall the second identity that we had, tan square theta plus 1 is equal to sec square theta. Yes. And from this we can write 1 is equal to sec square theta minus tan square theta. If you see, this is sec theta square, sec theta whole square. Yes, sec theta whole square. But sec theta is nothing but reciprocal of cos. That means I can write 1 by cos theta in place of sec theta. Yes, clear? So I'll get 1 by cos square theta, this. Yes or no? So you can see that if I write this first term, okay, as sec square theta, then I'll get sec square theta minus tan square theta, that will be equal to 1. Yes, so here I can write 1 by cos theta whole square. Yes, but 1 by cos theta is what? Sec theta. So I'll write sec theta whole square. This sec theta I've written for this whole thing, 1 upon cos theta. Then next you get sec square theta minus tan square theta. Yes, and in next step I can write this is equal to 1. And why I'm writing? Because I have got one identity which is tan square theta plus 1 is equal to sec square theta. So from this identity, sec square theta minus tan square theta is equal to 1. Okay, so using this identity I have been able to write this equal to 1, so which is equal to RHS proved. Okay, now next question number 5. Here we have tan square A into cos square A is equal to 1 minus cos square A. Okay, one more thing before we do this question. If I'm writing sin square theta, okay, sin square Once again, if I'm writing sine square theta, this means sine theta whole square. Okay. And if I'm writing like this, cos cube theta. Okay. This means cos theta whole cube. Okay. So please remember these things. It doesn't mean that if I'm writing sine square theta, then sine square is separate and theta is separate. No. If I'm writing sine square theta, it means sine theta whole square. Okay. Now let us see this question. So here LHS is equal to tan square A into cos square A. Now what I can do to this, and one more thing, if I'm writing tan square A, then you know that tan A is sin A upon sin A upon cos A. Yes, then in that case tan square A will become sin square A upon cos square A. Okay, so here your tan square A can be written as sin square A upon cos square A into cos square A. You can give the reason over here, since tan A is equal to sin A upon cos A. Okay, since tan A is equal to sin A upon cos A, so tan square A will be equal to sin square A upon cos square A. So now what happens, your cos square A and here cos square A cancel. Yes, and you are left with sin square A. But we are not done yet. This should be equal to 1 minus cos square A. So you know that sin square theta plus cos square theta is 1, and from this identity you can write that sin square theta is equal to 1 minus cos square theta. Yes, so this sin square A can be written, since we are talking in term of A, angle A, so we have to write 1 minus cos square A. Okay, which is equal to RHS. Done. So this is proved. Okay, and you should write reason over here, since sin square theta plus cos square theta is equal to 1. Okay, so this was question number 5. Now let us see question number 6. So question number 6 is this: tan theta is equal to sin theta upon 1 minus sin square theta. Now in this case you can see that the right hand side involves more terms than left hand side. Yes, so it would be better, okay, it would be advisable to start with right hand side. Okay, so it's not necessary that we always take left hand side and show it equal to right hand side. You may take any side, okay, whichever you feel you are comfortable in. Okay, so here let us take RHS. RHS is sin theta upon square root of 1 minus sin square theta. You can see on the left hand side, at the end you need to show that this right hand side is equal to a single term, that is tan theta. That means you need to reduce the number of terms you have on the right. Okay, so 1 minus sin square theta can be written as what? It can be written as cos square theta. Reason is what? Because we have one identity, sin square theta plus cos square theta, that is 1. Yes, so from this identity we are able to get that cos square theta is 1 minus sin square theta. Yes or no? So here in under root, in the next step, instead of having 1 minus sin square theta, I can have what? I can have cos square theta. Yes, Now, as I had told you earlier that when I'm writing cos square theta, okay, it means cos theta whole square. Yes or no? So I can write sine theta upon under root cos square, sorry, cos theta whole square. Yes, and you know that when we are looking for when we have under root, in that we from there we take, from each pair we take out 1. Yes, or when I write x square, square root of x square, then simply you get x. Yes or no? So here what you get, here you get sine theta, and down you get cos theta. Yes, but you know that sine theta upon cos theta is what? Tan theta. Yes, which is your left hand side. It is proved. Okay, here in the second step I didn't mention that why did I write this cos square theta. So you may write over here. Okay, you may give the reason. This was simply rough for you, just for explanation. So you can mention over here that the reason is sine square theta plus cos square theta is equal to 1. Okay, this is the reason, and these are clear to you. Okay, so this was your question number 6. Now let us see question number 7, and next is question number 7. It is 1 plus cos theta upon sine square theta is equal to 1 upon 1 minus cos theta. Okay, so here I will start with left hand side. So left hand side is equal to 1 plus cos theta. And one more thing I would like to tell you, that these things comes with practice. Okay, so more you practice, more comfortable you get with this type of question. Okay, and so you all are suggested to practice more and more this type of sums. Okay, now so here 1 plus cos theta upon sine square theta. So this sine square theta can be written as 1 minus cos square theta. Okay, using the first identity. Yes, using the first identity. Using this identity, you can get sine square theta is equal to 1 minus cos square theta. Yes or no? So what I will do is, in the next step, instead of sine square theta, I will write 1 minus cos square theta. So I'll get 1 plus cos theta upon 1 minus cos square theta. Done till here, and this is your reason. Yes. Now try to recall this formula. A square minus b square is equal to a minus b, okay, into a plus b. We have one formula like this. Yes or no? So here, if you see in the denominator, can we write the denominator in this form? 1 square minus cos theta whole square. Yes, cos square theta means what? Cos theta whole square. So you can see that this is your a square and this is like b square. Okay, where a is 1 and b is cos theta. Yes, so using this formula, okay, so when you have this, then when you factorize you get this. Yes, so we can write 1 plus cos theta upon 1 minus cos theta, because formula is what? A minus b. So here a is 1, b is cos theta. Yes, and then 1 plus cos theta. Now here what do you observe, that in the numerator you have 1 plus cos theta. Here in multiplication in the denominator you are getting 1 plus cos theta. So what will happen? These two will cancel. Yes, so you are left with 1 upon 1 minus cos theta. This is what we were looking for. Yes, so it is proved. Done. So let us keep it till here for today. Okay, thank you.